You mentioned TCP, and the reason why we do that is because so many applications, critical things that are running across our networks use it. We did promise you, though, 3 core things you need to learn about TCP. If you're going to be doing TCP analysis, you've got to master these 3 things.
I mean, it's important to highlight, right? You do this day in and day out. So this is not theoretical classroom stuff, but you're sharing it with us, but you're sharing a lot of your real world experience.
What we just walked through are the 3 things that you need to know about TCP. And these are important concepts to really master and show you what really matters and what helps me do my analysis.
Hey everyone, it's David Bombal back with the amazing Chris Greer. Chris is the person I talk to always when I want to know how Wireshark really works. Chris, great to have you back on the show.
Great to be back, David. Thanks for having me back.
Now, Chris, I mentioned Wireshark there, but it's actually the protocols that you're analyzing that's important. And I know you really like TCP, and I'm hoping you're going to tell us like some of the most important things to know about TCP.
Yeah, you said it well, David. Sometimes we're talking about the analyzer itself, that is Wireshark. But a lot of times we're talking about what Wireshark helps us to analyze, and that's going to be protocols on the network. You mentioned TCP, and the reason why we do that is because so many applications, critical things that are running across our networks use it.
I've got to say this because this comes up a lot whenever I talk about TCP, and it happened on our previous short, which I put on my channel. People say TCP is dead. It's been replaced by QUIC and UDP. What's your answer to that?
No, I don't think that's quite true, at least just yet. Now, over the web, yes. QUIC is starting to have more and more of a foothold each passing day. QUIC runs over UDP, and a lot of the mechanics of TCP still live on within QUIC. I know we've talked about that previously on your channel.
Yeah.
But TCP itself is still alive and well. It's still delivering enterprise applications. It's still delivering a lot of important systems and structures. So it is here, and I think it's going to be here for a very long time.
And AI is going to replace us, right, with packet analysis?
AI is going to help us, just like it's doing everything else. So even myself, I'm starting to use more AI tools in my analysis, but that doesn't mean that we still don't have to know what's going on. For me, the expression I try to share in my courses when I'm teaching Wireshark is try not to automate what you don't understand.
Yeah.
So if you don't quite know how something works, be careful about just running to AI to do the work for you, because that's where once something breaks and you have to troubleshoot it, that's when we'll be in trouble.
So Chris, that's enough talking. I'm going to hand it to you. Show us your top 3 tips or the top 3 things that are most important to know about TCP.
Yeah, let's focus on that. And I think it's important. It's something I'm passionate about. So let's get to the packets. All right, we all came here for packets. We are packet people, including you, David. So let's get into it. So here, I'm just going to open up my little screen. And I was just doing an analysis for another client. So you're live, real time, seeing what I was looking at least with the profile that I'm using. I'm actually going to do a little bit of cleanup here so people can see some of the things that I'm going to adjust for this specific analysis. If I take a look at time of day was interesting for me. So I'm just going to come up here. I'm just going to say seconds since seconds since first captured packet. What that does is it just resets my timer. First packet is 0. And then as things go on, I can see how the packets hit the analysis point. I'm going to leave that alone. People know I love delta time, so we can just link in a video here to show how to add that. Source to destination, we are alive and strong there. Protocol, got DNS and TCP people. TCP length. So if you don't have that in your Wireshark right now, all you got to do, just click on packet 4, which we have shared this PCAP in the description down below. So go get it. If you expand TCP, I'm going to come down here to TCP segment length, and you can take that, literally physically drag it and drop it up to your column header up here. And boom, you've got the same thing that I do. Now you might also, in your copy of Wireshark, also have a length that's already there. All you got to do, right click that column header, and you can just click and unclick any column headers that you see up here. By the way, quick side point, everybody. A question I usually get when I'm showing all this is, how can I get mine to look like that, Chris? Can you share your profile? We did that as well. There's a link in the description down below where you can import my TCP plain profile, and you can get all of my coloring rules. You can get my buttons up top and all of the stuff that I got configured here for Wireshark. So we'll share that as well.
That's great.
I got IPTTL as well. That's something I like to use. If you don't have that, let's go down to the IP header. Going to come down to the time to live. Again, drag, drop, boom, and that'll give you IPTTL. For me, for now, I was just looking at a PCAP where VLAN ID mattered. I'm just going to take, and I'm going to remove that for now, because guess what? I've got a real job, David, and I got to get back to that after this recording, believe it or not.
I mean, it's important to highlight, right? You do this day in and day out. So this is not theoretical classroom stuff, but you're sharing it with us, but you're sharing a lot of your real world experience.
You just watch my brain work through, the packet list and just try to reset some column things back to what might be a bit more simple as we're approaching this PCAP. And if you notice, David, check out the website that we're hitting.
Some dodgy website there.
Yeah, sketchy. Now, there's a reason I wanted to do this, David, and that was to show, well, I'm in the United States and your website is hosted, well, the actual site is in Europe. So let's just see what we hit. Did I cross the pond? What can we learn? And how can we use TCP to do that? We did promise you, though, 3 core things you need to learn about TCP. If you're going to be doing TCP analysis, you've got to master these 3 things. Okay? The first one is the handshake. Now, we've talked at length about this on previous videos about the handshake. We've gone in and we've ripped it apart. I'm not going to do that level of detail now, but there's a huge reason why you got to know the handshake and you got to be able to read it quickly. So you're going to watch in real time how I dissect a handshake. Then I'm going to back up and talk to you about why I look at some of those things. So first, just with my eyes, in order to establish a TCP connection, I first got to have an address that I go hit. To get that, DNS up above. So first thing my machine did is I did 2 DNS queries. One was for an A record. The other is for an HTTPS record. Let's just focus here on the A one because that's going to give me my address that you see down below. So I hit DNS server. Hey, give me davidbaumel.com. What's the IP for that? DNS server comes back. DNS server says it's 217.160.69. There you go. I actually want to show you something really cool. David, you want to see something that's super fun?
Chris, that's a rhetorical question, right?
Oh, I'd hope so. And I hope all of your audience was like, yes, let's see something cool. So I can set a filter for a value that is within a packet, even if that filter looks for packets other than the one I'm clicked on. Okay, that was a mouthful. Let me back up and show you what I mean. Packet 3, and if I come down into packet 3, what I'm looking for here in DNS, I'm going to come down here to answers, and I want that IP address. Bam. That's the address that the DNS server responded.
Yep.
Now, in the future, we're going to do more deep dive on DNS, but for now, all I got to look for down here is see DNS.A.
Yep.
Down there, down at the bottom. I know it's kind of like small and stuff, but what I want to do is I want to pull that address out of this DNS record and apply it as a TCP conversation, or rather look at all conversations coming to and from that IP that DNS responded. So this is what I'm going to do. I'm going to say, show me IP.adder. Okay. I want everything to and from the address. I'm going to do a $, curly brace, DNS.A, close curly brace. What that filter does is it's going to rip this value, DNS.A, out of the packet that I am clicked on and apply it as the value. It's basically going to fill in this value with that IP address. Okay, so let's see it happen. Bam. So now the DNS is gone because I'm not interested in DNS traffic, right? I just wanted the value that the DNS packet had. So I ripped that field out and I added it to a filter that was filtered on a different conversation. Does that make sense?
Yeah, no, it does.
Cool. Now, just in case you don't have this, I'm actually going to share this profile so you will when I do. I'm going to say plus, I'm going to add this because this is a filter I want to have around. So I'm just going to say, how about extract IP DNS, maybe underscore DNS. There we go. I'm just going to leave that for right now, everybody. And I'm just going to say, okay. And it's going to be up here on the top right. So now in the future, whenever you're looking at DNS, you come to one that has an IP address in it. You just come up here and you click that and boom, you're going to have a filter for that conversation. All right. Back to TCP. Handshake is the first one you should look at. So the very first thing my eyeballs do, I'm looking at a SYN. Now a SYN packet is initiated most often by a client. The client connects to a server. So in this case, 422, that's a client side. Server side, this is David's IP, external facing, and I send that SYN out. Now in other videos, we've talked at length about what kind of stuff gets exchanged, options, all the things. We're not going to, for the sake of time, we're not going to do that this time. But my eyes are just going to scan down just to see, okay, there's my window size, got some options going. Now there's 3 options I really want to watch for every single time. One is MSS, one is window scale, one is SAC permitted. Those are, I call them the big three. Those really establish modern options into the TCP conversation. TCP, not all TCP is the same. Not all TCP stacks are equal. So when they first establish a connection, they first establish parameters between the two, and then they decide what kinds of things they're going to use. So I'm advertising to you, David, 1460 MSS, window scale of 6, which gives me a multiplier. That basically allows this window size to be much larger. That window size is a receive TCP buffer. So I'm saying, hey, David, if you send me a bunch of data, I'm going to be able to catch it because I'm going to give you a bunch of space to work with. And then SAC permitted, selective acknowledgement. Just in case we see any missing gaps or spaces in the data flow, we can use selective acknowledgement to allow data to keep on being sent while we are recovering from previous packets that went missing.
So, Chris, I just want to clarify, right? The reason we need this SYN is we need to agree a bunch of stuff. I could have a very old client. You could have a very modern server. And that's why we need this negotiation, because you need to find out what I support. I need to know what you support. Does that kind of make sense?
Yes, but let's also use a different word than negotiate. Let's drift away from that for a minute. Let's use advertise.
Okay.
Right? So client, hey, I want to talk to you, server, and this is what I'd like to use.
Yep.
Server comes back saying, okay, cool. This is what I'd like to use.
Yeah.
Right. And we both have to support SAC. We both have to support window scale. I mean, check out, David, look at your window scale. It's double the size, or it's the multiplier.
Yeah.
It's a double factor. This is a scale factor, which goes into this multiplier, which then allows you to have a big, like just the receive buffer is going to be huge. So I know we went to some detail, but all of these concepts are things you can learn much more about on my channel. I deep dive and dissect every single one of these fields, when to use it, why to use it, how to understand it.
Yeah.
But these parameters within a handshake are things that you want to learn the reason. So you, like me, when I'm scanning through, now I go boom, and I just look through, pop, 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 okay, boom, pop, 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 pop. All right. I just analyzed the handshake. Your brain starts to do it because you understand where to look and what matters, right? Now, a big thing that I'm going to focus on in the handshake is my delta time between the SYN and SYNAC. Now, SYN, so I send out my SYN, which means synchronize. We'll get to what it synchronizes in just a minute. Send that out to the server. Server turns around 130 milliseconds later, I get a SYNAC. Now, as a client, I'm starting a stopwatch and stopping a stopwatch. This now gives me my network round trip time, okay? And in the handshake, Wireshark actually, if I come down to sequence and acknowledgement analysis, that IRTT that you see at the very bottom, that value is basically the 3 packets of handshakes in SYNAC ACK, and it's these delta times added together. So that then gives me my initial round trip time of my network. Nice. So right now, David, I just put that on a pegboard of truth. I mentally tucked that away. I got 130 milliseconds between me and your server. What do you think?
It's a long time.
Yeah, that's a little bit of network that we have between us. Now, is that bad? Well, if your server was on the same floor as me, if we were in the same building, then yeah, we got some problems, right? But we have a whole ocean between us. Yeah. So I start to factor that in. Another thing that I do with the SYNAC is I also look at the ingress IP TTL. And the reason there is I can see this value is 54. I'm just going to show you where that comes from in the IP header. Come down to TTL 54. What this means is this is as I am receiving it. So when this value started, this TTL, it's likely that this began at 64 on your end. The reason why, there's 3 common values that TTLs begin at: 64, 128, and 255. That's what these numbers typically start with. You see that on my direction. I started at 64. Your machine likely started at 64 as well. And as it was decremented across the internet, as it came toward me, then I caught it at 54. That means it was decremented 10 times. That means 10 routers or layer 3 switches decremented that value on its way to me. Yep. So now that gives me a bit of a context as far as how many routers I passed through. Does that make sense?
Yeah. Every hop lessens it by 1, right?
That's exactly it. If we ever hit 0, packet gets dropped.
Yeah.
Right. And the reason why I know that this isn't 255 is because, man, we would have gone through 200 routers.
Yeah.
The way I know it's probably not 128 decrementing down to 54, well, that's a whole lot of routers too. So 10 makes sense. So I'll just mentally note that. So I got 130 milliseconds of network round trip time. Likely my server is the endpoint that I'm communicating with anyway is 10 hops away. And then I finally wrap that up. So those pieces of the handshake are very critical. You're doing TCP, you should be able to do what I just did in minutes. SYN, SYNAC, ACK, the IRTT, look at your network round trip time, look at your ingress IP TTL and your SYNAC, and look at your TCP options. Make sure that you have MSS, make sure you have a window scale, make sure you have selective acknowledgement for most cases. Generally speaking, those are the three that you want to see.
That's great. I mean, it's a lot of information, Chris. You said you're going to show us three things. This is only the SYN part, right?
Yeah, this is just in the handshake. This is the SYN, SYNAC, ACK that you see.
So explain what SYN is and explain what SYNAC is and explain what an ACK is.
All right. Very good. Thank you for that question. And that actually gets us, you just led us into the second thing you need to learn about TCP,
great.
Sequence numbers.
Okay, great.
Part of the reason why this is called SYN is because we are synchronizing sequence numbers. Okay, so if we go back into the SYN, and I don't mean to be moving too quickly, everybody, but I just want to keep it to the three things you got to study more. So in the SYN, just click on that first packet, and then you're going to come down to sequence number raw. So this is a value that the client calculates, comes up with. Don't worry too much about how. Just it's a high numbered, hard to guess number that it selects. Okay. And there's a whole calculation that goes into that. Let's leave that to the side. But for right now, big, weird, unique number. I send that to you, David. And I say, hey, David, I'm going to start counting at this number. What this number is does not matter. You just need to know where I'm starting to count from.
Yeah. Okay.
This is the whole reason why it's called SYN. I am sending this value to you. You, in turn, add one to it. You use basically when I send you a SYN, when you have a SYN flag in a packet, the whole system acts like one byte was sent. It's called a ghost byte or a phantom byte. Pick one. It's just a false one. And what you do is you add one to this value and you echo that number back to me. Okay. So what I'm going to do is, what I'm going to look for here is I've got 7859. I want to see 7860. I just added one to this value. I want to see that in your SYN ACK field, 7860.
Nice.
You just plus one'd it and sent it back. And I said, cool. David heard me. David heard my SYN. He added one and he echoed it back in the ACK number.
And that means I know what your starting number is, and you know that I know that.
Correct. You at the same time sent me a totally different sequence number. These two numbers right here are different. They don't intersect. They don't add, multiply, subtract, divide. There's absolutely no mathematics between them. You just told me, hey, Chris, I'm starting here. So what I do is I say, David, cool. So 3112, I'm going to send 3113 back to you.
Yeah.
In the form of my ACK numbers. Let's see if that happens. 3113. Yeah. I advanced one to 7860. So now I have moved forward one in my sequence number direction. You have now moved forward one in your sequence number direction. We just synchronized sequence numbers. So there's two things we just learned. One, we learned more about the first thing we need to master, and that's the handshake. The whole point, the reason why it's called a SYN is because we're synchronizing sequence numbers. The second thing that we're starting to learn is sequence numbers themselves. Sequence numbers, basically in the RFC for TCP, it says every single byte has an associated sequence number. What this allows me to do is when I send you traffic, David, every byte that I send increments that sequence number. That way, through feedback from you, I can see what went missing and what was successfully received.
Question. One number in the sequence number, is that one byte of data?
That's correct.
Okay. Just to make it obvious, if I increase the sequence number by 5, that means 5 bytes of data have been sent.
That's correct.
Okay.
Now you should see 5 bytes of data being sent.
Yeah.
Right? In fact, while we're at it, I like that question. Let's go to packet 8. Here the client is sending 1448. Right? So we're starting at 7860. We're going to add 1448, and that will be the number that gets ACKed back to us.
So it's TCP length, segment length is the number of bytes that are being sent.
That's the payload. That's why I like TCP length up here, because I can see which packets have payload and which ones do not. Now, as you can imagine, some of this math gets a little crazy.
Yeah.
Because here's a payload and here's a sequence number raw and all that stuff. That's why Wireshark does us a favor. It does us a solid, we say. It zeroes out these sequence and acknowledgement numbers, and it does that with a relative sequence number. So I'm going to go back up to my SYN. You can see my sequence number, my raw value.
Yeah.
Right above that is sequence number 0. So what Wireshark is saying is, in context to this conversation, relatively, let's just start this sequence number over at 0 because you humans can't count worth beans.
Yeah.
Terrible counters. I'm a computer. I can count. That's not hard for me. I don't care if I start counting from some crazy high value. I can do that easier than you. So the masters of Wireshark did us a big favor just by saying, let's just zero this number out and act as if it was 0. That way, when you count, you're counting up the number of bytes relative to this conversation. Does that make sense?
Yeah, no, so much easier to read.
Oh, much, much, much easier. Now, that said, they do keep the raw value there just so we know what it is, just so in case that's valuable to us. Okay, but if we come down here to packet 8, so here my sequence number has advanced by 1 in this direction. The ACK number also advanced by 1. All of that happened in the handshake. So here I'm on sequence 1. I'm sending 1448 in this direction. 1 plus 1448 equals 1449. My next starting sequence number in this direction will be 1449. I'm going to move forward to 1449 in conjunction with the number of bytes that I send.
And it's important to highlight, right, even though it says they both start at 0, right, but the numbers are actually got nothing to do with each other because the real numbers are these crazy numbers.
Good call, David. That's exactly right. It's the two true raw values are the ones that truly move data. But just for our analysis, that's what these relative numbers are, just to make it simpler.
Correct.
Now, if you notice here, packet 9, I've got another loaded packet. This is a TLS client hello, which, by the way, we'll talk about you doing TLS 1.2 in just a second. There's 345 bytes in this packet. So let's come down here and see what the math is. So my sequence number is 1449. So we see why we're there, right? Why are we at 1449?
Yeah, we started at 1 and you added, what's it, 1448? Yeah, in the packet above.
That's correct. So now I move forward to that point. I'm starting sequence number 1449. This time I'm adding 345 to it. That's my payload. The next starting sequence number that I should expect in this direction is 1794. Wireshark's doing the math for us. Sequence plus length equals next starting sequence number.
Nice.
At the same time, David, if both of these packets get to you, this is the value 1794 that I should see you reply as an ACK number.
Yeah.
It's the next sequence number that you expect. Okay, so let's see if that happened. Packet 10. Sure enough, ACK number 1794. David got both those packets. So now I no longer have to figuratively keep back a copy of that 1794 bytes, right? I can now move forward like, okay, David got it. Hey, boys, you can dump that out of the send bin. We don't need to keep that data anymore. We can just move on, right? We can move forward in our stream. So I don't have to retransmit. I'm happy. And I come over here with my eyes. 131 milliseconds is how long that took. That loosely, or very, very close, I shouldn't say loosely. This very closely represents our network round trip time.
Yeah.
So I'm not surprised there. All right, how are we doing so far?
That's great. So can you just go through it again, Chris, just to reiterate? So we started 0, but you sent 1 byte, right? And then the next time you sent 1448. And then the third time you sent 345. And that's how we got to that total amount. Added together, then the server acknowledged that plus 1 because it's the next piece of data that it's expecting. Is that correct?
Good review. Exactly. And you just went through basically the things that we want to know about TCP. So in our handshake, we synchronize sequence numbers.
Okay.
I send you a high number value. You send me a high number value.
Yep.
I plus 1 and you plus 1.
To start us off. Yeah.
Yep. That's why it's called SYN.
Yeah.
Then both of our relatives go up by 1 because we just plus 1 in each direction. So now my starting sequence number is 1. Remember, Wireshark's zeroing that out for me. Now I have my connection established. Now I can start moving forward with my sequence number. Packet 8 is the first one with real data in it. Sequence number plus length equals next sequence number.
Nice.
Next sequence number plus length equals next sequence number. Now these two packets went out back to back. I had so much to say to you in this client hello that I had to bust that apart into 2 packets.
Yeah.
So that's why there was 2 going out. Now those 2 float along and they go across the Atlantic Ocean and then they land and then boom, they get processed by your TCP stack. Your TCP stack goes, oh, cool, great. So this is a packet with 1448 and then 345. Let's add all that up and send Chris back a 1794 as an ACK number. If you didn't, I'm setting a stopwatch in each of those packets. As I send this out, once I send it, I start a stopwatch. And if I don't hear an ACK number that acknowledges this data within that period of time, when that stopwatch expires, I'll retransmit. Again, that's another conversation we can have, like the mechanics of that with TCP and how that's also important to understand. But for now, I just want you to know this has to get acknowledged. Otherwise, I'll retransmit. All right. So then you pick up and just to kind of wrap up this part of the conversation, then you start to send. And if we take a look at your sequence number, if you look at packet 11, so your sequence number is 1. You haven't sent me anything yet, right? The handshake doesn't count. It's just a ghost byte or phantom byte, and you've ACKed, but you haven't sent anything else. This is your first actual piece of data.
Yeah.
Now, something else that my eyes do, everybody, with TCP, packet 11, is this 27 milliseconds. That is basically application response time. This is David's server saying, great, I got your stuff. This is how long it took for him to actually begin to respond.
Trash server.
Not really. It happens. I mean, 27 milliseconds, I'm not super worried about that. I mean, no one picks up the phone and calls me for 27 milliseconds. Now, if it happened 100 times, then yeah, that's what you called me for. But so far, not super worried about that. You start at 1, send me a loaded packet. You move forward in your sequence number, you send me a loaded packet. You move forward in your sequence number, you send me a loaded packet. Then you pause. That was your server hello, those 3 packets that came over from you. Your next expected sequence number in this direction is 4097. I take that value, I take all that stuff, and I send you back 4097. I'm telling you, David, I got you. In fact, Wireshark gives us a visual. You see this little check mark over here by packet 13?
Yeah.
When I've clicked on 14, Wireshark says you're good all the way through packet 13. Thumbs up.
That's nice.
What we just walked through are the 3 things that you need to know about TCP. And these are important concepts to really master. The handshake, we talked about that. We talked about the sequence numbers. And we actually already talked about the third thing, and that's acknowledgement numbers. If you can master those 3 things, David, you are going to be fine in your TCP analysis. Of course, there's more to learn, but everything else builds on that foundation.
So I wonder, this I've seen this multiple times. Let's say you send me 1,000, right? So your sequence number is 1,000. Do I ACK 1,000 or do I ACK 1,001?
You send me back an ACK for the next sequence number that you expect to receive. So you're actually 1 more than the actual data that I sent you. So if I'm starting off in sequence number 1 and I send you 1,000, you're going to ACK back 1,001.
Yeah.
You're literally adding sequence number plus payload. And that's the next sequence number that you expect me to start at.
That's great.
So hopefully that answers your question.
I love that. The way you answered that right at the end makes a lot of sense. So it's the next number that I expect you to start at. Yeah, great.
Correct. This is the next one. Like, I'm good all the way up to here. This is the next place I expect you to start.
Yeah, that's great. And you know, based on, like you said it earlier, that I've received all the previous data. So you can dump that and start at the next piece of data.
Correct. Once your acknowledgement number goes forward, it shouldn't ever go back down.
Okay.
Right? Once you advance, once I say, hey, David, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the biggest number you heard me say?
10.
Okay. I don't ever have to repeat 1 through 10 again.
Yeah.
Like, you got everything before that? We're good? Okay. 11, 12, 13, 14. Like, I don't have to, you're never going to back down and say 3.
Yeah.
And if you did, either that's an ACK that came in out of sequence, or I got to do some deeper analysis and figure out, like, why are things getting switched around here? So
that's brilliant, Chris. On your channel, right, you go through this stuff in a lot more detail, as you said. So do you have a playlist or something where people can start on your channel?
Yeah, I have a How TCP Works playlist, and we can link that as well. And when you check that out, what I try to do, Dave, is just bite-size videos, just somewhere between 5 to 10 minutes. And I literally go through each one of these little things that you've seen. And over time, I'm just refreshing that, just adding more content to it, giving you more PCAPs to look through, because I really think that each one of these things is important. However, I understand the overwhelming feeling that it can bring, especially when you're first looking at this. It's like, what matters? I think that can be a barrier of entry into Wireshark. It can make us feel like, man, why get it started? I don't understand all this stuff. And Chris is just ripping through it too fast. So that's my goal on my channel, is to give you examples, scenarios, PCAPs around these different values and show you what really matters and what helps me do my analysis. So yeah, so I definitely invite people to check that out. over on my channel, How TCP Works, that playlist.
So for everyone who's watching, please go and sub, show the love. Chris is the person I always talk to when I really want to know how Wireshark works and protocols like TCP and UDP. Chris, thanks so much for sharing.
Thanks for having me, David, and hopefully I'll see you again.